Hello children, today we shall start with the second part of this video for the chapter Analytical Chemistry. So what did we see in our previous video? Let's have a recap. First we saw the definition of analytical chemistry. Analytical chemistry, it is the branch of chemistry that deals with the methods of analysis of chemical substances. Then we saw color of salts and their solutions. Salts of copper and iron are colored and hence their solutions have distinct colors. Salts of calcium, zinc and lead are colorless and hence the solutions of their salts are also colorless. Then we saw the action of sodium hydroxide on salts and action of ammonium hydroxide on various salts. In today's video, we will see the amphoteric nature of substances. In that, we shall cover action of zinc, lead and aluminium on caustic alkali. What is caustic alkali? That is sodium hydroxide or potassium hydroxide. They are referred to as caustic alkali. Then we will see the amphoteric nature of oxides of zinc, lead and aluminium. After which we will see the amphoteric nature of the hydroxides of zinc, lead and aluminium. So first let us start with the action of zinc on caustic alkalis. So how does zinc react with the caustic alkalis? So let's start with sodium hydroxide first. Zinc reacts with sodium hydroxide to give sodium zincate and hydrogen gas. Zinc reacts with sodium hydroxide to give sodium zincate and hydrogen. Zinc reacts with potassium hydroxide to give potassium zincate and hydrogen. So with sodium hydroxide it gives sodium zincate and with potassium hydroxide it gives potassium zincate. Now let us see the action of lead with caustic alkalis. Lead reacts with sodium hydroxide to give sodium plumbite and hydrogen. Children, I like you to note in this reaction the one that is underlined, sodium plumbite. We get only one molecule of sodium plumbite. Children, referring to APC textbooks, in this textbooks there is a misprint of 2 molecules of sodium plumbite. So there is a coefficient 2 before sodium plumbite, which should be 1. So I would like you all children to make the note in your textbooks. Let's continue. Lead reacts with potassium hydroxide to give us potassium plumbite and hydrogen. So with sodium hydroxide we get sodium plumbite, and when lead reacts with potassium hydroxide we get potassium plumbite. Coming to the next one. Action of caustic alkali on aluminium, means how does aluminium react to sodium hydroxide and potassium hydroxide. Okay, so in this reaction of aluminium with sodium hydroxide we also need water. Aluminium reacts with sodium hydroxide and water to give us sodium aluminate and hydrogen. We get sodium aluminate and hydrogen, and when aluminium will react with potassium hydroxide, here also we need water. In this case we get potassium aluminate and hydrogen. So aluminium reacts with sodium or potassium hydroxide and water to give us respectively either sodium aluminate or potassium aluminate and hydrogen gas. Now let us see the amphoteric nature of the oxides. So how do the oxides of zinc react or show amphoteric nature? So first of all, what is the meaning of amphoteric nature? Amphoteric nature means when any substance can show acidic as well as basic properties. So first let us see the basic nature of zinc oxide. Zinc oxide reacts with hydrochloric acid to give zinc chloride and water. So what we see is zinc oxide reacting with the acid to give us salt and water, and hence it's showing its basic nature. Now let's see its acidic nature. Zinc oxide reacts with potassium hydroxide to give us potassium zincate and water. So in this case, it acts as an acid. Why? Because it is reacting with a base to give us salt and water. Now, since zinc oxide shows both basic as well as acidic nature, it is considered to be an amphoteric substance. Now, let's see the amphoteric nature of lead oxide. Lead oxide. We'll start with the basic nature. The basic nature of lead oxide. Lead oxide reacts with nitric acid to give us lead nitrate and water. So we get a salt and water when lead oxide reacts with the acid. So it shows its basic nature. Let's see its acidic nature. Lead oxide reacts with potassium hydroxide to give us potassium plumbite and water. So in this case, lead oxide reacts with the base to give us salt and water. Since lead oxide shows both basic as well as acidic nature, it is considered as amphoteric. Now let's see the amphoteric nature of aluminium oxide. So let's see its basic nature first. Aluminium oxide reacts with hydrochloric acid to give us aluminium chloride and water. Hence it shows its basic nature. It's reacting with the acid to give us salt and water. Now let's see the acidic nature. Aluminium oxide reacts with sodium hydroxide to give us sodium aluminate and water. So with a base, it gives us a sodium aluminate salt and water, and hence it is acidic. Since aluminium oxide shows both acidic and basic natures, it is considered to be amphoteric. So this is the amphoteric nature of aluminium. Now, since we have seen oxides, let us go to hydroxides. Let's check out the hydroxides of all these three elements. So first, starting with hydroxide of zinc. So we'll see the basic nature of the hydroxide of zinc. Just like the oxide of zinc, the hydroxide of zinc also reacts with the acid to give salt and water. So in this case, zinc hydroxide reacts with sulfuric acid to give us zinc sulfate and water. Now let's see the acidic nature of zinc hydroxide. Zinc hydroxide reacts with potassium hydroxide to give us potassium zincate and water. So in this case, we see that it acts as an acid because it is reacting with a base to give salt and water. Now let us see the amphoteric nature of the hydroxide of lead. So let's see how lead hydroxide shows its amphoteric nature. First, we'll see its basic nature. Lead hydroxide reacts with nitric acid to give us lead nitrate and water. So it shows its basic nature here. It is reacting with the acid to give us salt and water. Now let's see its acidic nature. Lead hydroxide reacts with potassium hydroxide to give us potassium plumbite and water. So here lead hydroxide is reacting with a base to give us salt and water. Hence it shows its acidic nature. So we can see the acidic nature of lead hydroxide here. So since it shows both basic and acidic nature, lead oxide is showing amphoteric nature. Now let's see the last one, that is the amphoteric nature of aluminium hydroxide. First we will see the basic nature of aluminium hydroxide. Aluminium hydroxide reacts with hydrochloric acid to give aluminium chloride and water. So we get aluminium and chloride and water when aluminium hydroxide reacts with an acid like hydrochloric acid. So it shows its basic nature. Now let's see the acidic nature. Aluminium hydroxide reacts with the base sodium hydroxide to give us sodium aluminate and water. So when aluminium hydroxide reacts with sodium hydroxide, we get sodium aluminate, which is a salt, and we also get water. And this shows the amphoteric nature of aluminium hydroxide. So in this session today, we have seen the amphoteric nature of substances. First thing, we have seen the action of zinc, lead and aluminium on caustic alkali, that is sodium hydroxide and potassium hydroxide. Then we have seen the amphoteric nature of the oxides of zinc, lead and aluminium. That is, we have seen the amphoteric nature of zinc oxide, lead oxide and aluminium oxide. And we have also seen the amphoteric nature of the hydroxides of zinc, lead and aluminium. So this completes our chapter Analytical Chemistry.